We want to prove the sum and difference identities for sine and cosine. And we've got two angles, x and y, and so we need to create two triangles. And since we're looking at the sum, we want these two triangles to have those angles line up. So I'm going to start with one triangle here that's going to have an angle of x. Okay, and so this angle right here is x. And then I'm going to stack the other triangle on top, where I've got a right angle here. And that triangle now is, that has an angle of y. And so I've got a right angle there, and I've got a right angle there. I'm also going to call the hypotenuse of this top triangle. We're just going to say that has a length of 1, and then we'll go from there. The first thing I'm going to do is just find the lengths of these sides of the triangle. So I have all the lengths of the sides of the triangles that I see here. So we're going to start with this side over here. This side right here, this is the side opposite of y. For now, I'm just going to call that a. And notice that the sine of y, sine is opposite over hypotenuse. So that's just a over 1, which is, of course, just a, which means that this side right here is sine of y. So I'm going to go ahead and write that. So sine of y. I can similarly do the same thing with this line right here, which is the side adjacent to y. And you can see that the cosine of y would be this length over 1. So this length is the cosine of y. Now that I have that, that's the hypotenuse of the triangle that has the angle x in it. So if I wanted to find this side over here, we'll call that b. I can use the sine of x, and sine of x is opposite over hypotenuse, so that would be b over cosine of y. And so I can solve for b here and get b equals sine of x times the cosine of y. So that's this length right here. I'll go ahead and now fill that in. So I've got sine of x cosine of y. All right, now I can do the same type of thing for this length down here. Okay, and so if we call that length, we'll call that c, then we can say cosine of the angle x is adjacent over hypotenuse, so c over cosine of y, and then solve for c by multiplying by cosine of y. So I get c equals, okay, so then I can just fill that in right here. So I've got cosine of x and cosine of y. Okay, so now what we need to do, we need to figure out, we want a triangle that has x plus y as an angle. And x plus y, well, that's this full angle here. And if I want to create a triangle with that, I'm just going to take this line here as a hypotenuse and then drop a line straight down from there. And that will be, that's a right angle. And now this triangle is a triangle that has x plus y as an angle. So I know that I'd like the adjacent and the opposite of that angle, x plus y. And in order to do that, I'm going to use these lengths that I have so far. I'm going to start by taking this point right here, and I'm going to connect it straight over into a right angle right there. Now, there's actually an angle here that I can figure out. I'm going to start by looking at this angle x right here. And notice that this line is parallel to this line. So this is a transversal that's cutting through those parallel lines, which means that alternate interior angles are congruent. So this angle x is congruent to this angle right here. And it's really small. There's an x right there. Okay. Then from there, I see that this angle, which I'll go ahead and label this angle right here, is the complement of that angle. Okay, that angle is going to be 90 degrees minus x. Okay, and then finally I can move up to this angle right here. And those two angles have to be complements as well. Since I've got a 90-degree angle right there, I know that these two angles will add up to 90 degrees as well. So this angle is going to be 90 degrees minus this angle, 90 degrees minus x, which is just equal to x. So this angle up here, that's x, which is really nice because now I have another triangle which has an angle of x. And so now I can find these other two sides in terms of sine and cosine of x. We'll start with this side right here. That side right there, I'm going to call that, we'll call that d. And notice that cosine of x is adjacent d over hypotenuse, which is sine of y. And then I can solve for d by multiplying by sine of y. So d is equal to cosine of x times the sine of y. And that's this length right here. I'll go ahead and just label that there so we have it in the picture. The next thing we're going to look at is, well, actually now we've got enough to say, to write one of these identities. I'm going to go ahead and do this. The sine of x plus y, okay, is going to be opposite over hypotenuse. And opposite is this full height right here, which is that red part, plus this length here, which is sine of x cosine of y. And so I can add those two things together. So sine of x plus y is sine of x cosine of y, that height, and then plus this height here, d, which is cosine of x sine of y. So I've got one identity, and then we just need to get our cosine identity. And this one, there's just a little bit of more work to do. First of all, notice that if we're looking at cosine of x plus y, that's going to be using the adjacent of this triangle that has the x plus y. And so that's going to be this length from here to here that we'd like to find. And notice that we have this full length, cosine x cosine y. And so if I take that full length and subtract off this smaller length right there, I will get that length that I'm looking for. Well, that smaller length right there, notice that that is this length here, which is the same as that length right there. And so I can again find that. We'll call that k. And that length, notice that's the opposite of the angle x there. So sine of x is equal to opposite k over the hypotenuse of this smaller triangle up here, which is sine of y. And so I can solve for k by multiplying by sine of y. So k equals sine of x times sine of y. And now I can write my identity for the cosine of x plus y. The cosine of x plus y, that's the adjacent of this side that has a hypotenuse of 1, which is the full length cosine of x cosine of y minus this shorter length, which was the sine of x sine of y. So those are the proof of the sum and difference identities for sine and cosine. And we can also, from these, we can prove the formula for the sum identity for tangent. And I'll go ahead and do that down here. Tangent of x plus y, well, tangent is sine over cosine. So this is sine of x plus y over cosine of x plus y. And the formula for sine of x plus y, that's that thing right there. So we'll go ahead and write that out. Sine of x cosine of y plus cosine of x sine of y all over, and then cosine of x plus y, which is this formula here. Cosine of x cosine of y minus sine of x sine of y. And then there's one trick to this, and that is we're going to divide by this term right here, the cosine x cosine y term. So we're going to, on top and bottom, multiply by 1 over cosine of x times cosine of y. And of course we can do that because now we're multiplying by 1, which doesn't actually change it. It's just going to change what it looks like. And so taking this and distributing it to each of these terms, sine of x times cosine of y over cosine of x cosine of y, the cosine of y will cancel, and we get sine of x over cosine of x, which is tangent of x, plus cosine of x will cancel out, and sine of y over cosine of y, that's tangent of y. All over cosine x cosine y times 1 over that same thing is just 1. And then minus sine of x over cosine of x is tangent of x. And sine of y over cosine of y is tangent of y. So that's the proof of both the sine, cosine, and tangent sum identities. The question is, what about the difference identities? And this is really quick to do with any of these. I'm just going to do it with the sine formula. If I want to find a formula for sine of x minus y, all we do is we think of this as sine of x plus negative y. And then we can use the sum formula for the sine here. So this is sine of x times cosine of negative y plus cosine of x sine of negative y. And then we can use the even-odd identities for sine and cosine. Cosine is an even function, which means that the negative inside does not affect anything. We can just get rid of it. So this is just cosine of y there. And then here, sine is an odd function, which means that the negative can come out. So this now becomes minus, and then we have cosine of x sine of y. And that's the proof for the difference identity for the sine function. And proving it for cosine and tangent is the exact same process. Replace y with negative y in the sum formula, and then simplify using your even and odd identities.